Okay, this is POD 7.6 to 7.8 part 2. We already know all of these. I guess I can fill them in just for the sake of it. This is 4, 8, 16, 32, 64, 9, 27, 81, 16, 64, 2, 56, 25, 125, 36, and 216. These are square roots, so this should be 2, 3, 4, 5, and 6. Cubed root should be 2, 3, 4, 5, and 6. 4th root of 256 is 4. 4th root of 81 is 3. 4th root of 16 is 2. 5th root of 32 is 2. 6th root of 64 is 2. Okay? Very similar here to what we saw before. It's asking us to evaluate the root before the exponent. So this is 64 to the 2/3, and 64 to the 2/3 is the cubed root of 64 squared. Cubed root of 64 is 4. Squared is 16. It says, hint, rewrite the expression with a positive exponent if applicable. Well, we've got 9 to the negative 3/2. That would be the same as 1 over 9 to the 3/2. So now I've got 1 over the square root of 9 cubed. Square root of 9 is 3. Cubed is 27, so that should be 1/27. 16 to the negative 3/4. That's the same as 1 over 16 to the 3/4. And that is the same as the 4th root of 16 cubed, which is 2 cubed, which is 8. So that should end up being 1/8. 125 to the negative 2/3 is 1 over 125 to the 2/3. That's the same as the cubed root of 125 squared, which is 1 over 5 squared, or 1 over 25. So don't forget that the negative exponents scare us, but really they just mean divide 1 by that number instead of multiply. Is 5 an 8th root of 390,625? Is negative 5 an 8th root of this? Justify your answer. My guess is probably yes for both, but you're going to have to use a calculator to look at these, and I don't have one handy, but I'm going to say yes, possibly. If negative 5 to the 8th equals that, then yes, because that's how we define a root. So if 5 to the 8th is equal to that, then yes. So you'll need to check that. 6 says, find all real solutions to the equations, showing the steps that lead to your answers, round to the nearest tenth if necessary. Okay, m to the 6th plus 8 equals 9, then m to the 6th must equal 1. So if I take a 6th root of both sides, in other words, raise it to the 1/6 power, then I should get the absolute value of m, because I took an even root, is equal to 1, because 1 to the 1/6 is just 1. So m can be either 1 or m can be negative 1. So if I raise negative 1 to the 6th power, I get 1. 1 plus 8 is 9. If I raise 1 to the 6th power, I get 1. 1 plus 8 is 9. So both of these work. Again, when you take an even root, better have the absolute value. Okay, because we know that, for instance, the square root of x squared, that's the absolute value of x. It's not equal to x, because no matter what you plug in here, you will get out a positive. Okay, w to the 2/3 plus 1 equals 17. Then w to the 2/3 equals 16. Raise both to the reciprocal power. So I get w to the 2/3. I'm going to raise this to the 3/2, and I'm going to raise this to the 3/2. But I'm going to take note that I'm really taking a square root here, because I'm taking a square root and then cubing it. So absolute value w should be 16 to the 3/2. So that means that the absolute value of w should be the square root of 16 cubed, or 4 cubed, which is 64. So w could be either 64 or negative 64. And that's what we saw before. The cubed root of negative 64 is negative 4. But then when you square it, you get positive 16 plus 1 is 17. So either of these would work. This one I'm going to subtract 17 first, so 5c to the 5th is equal to negative 37. Divide by 5, c to the 5th is equal to negative 37 fifths. Then, this is an odd power function, right? C to the 5th or x to the 5th, so it's going to cross this number just one time, and it's going to cross at the 5th root of that number. Or I could write c equals negative 37 fifths, all to the 1/5 power. Those are the same thing. Coming over here to d, I've got x to the 6th plus 45 equals 16. So x to the 6th equals 16 minus 45. 16 minus 45 is negative 29. But x to the 6th can't equal a negative number. X to the 6th looks like this. Negative 29 looks like this. No real solutions. Finally, I've got x to the 4/7 minus 19 equals 58. So x to the 4/7 is equal to 58 plus 19, which is 77. Raise both sides to the 7/4 power. And I get x is equal to 77 to the 7/4 power. But I took an even root, so it should be absolute value x. So I should get x is equal to plus or minus 77 to the 7/4 power, which is also plus or minus 4th root of 77, all of the 7ths, depending on how I want to write it. Okay, finishing this one off. Determine the number of real roots possible. Justify your answer with a tiny sketch of the equation involved. 4th roots of 20. Solutions to the equation x to the 4th equals 20. Right, because if we're going to solve this, I take a 4th root. Well, x to the 4th looks like this. 20 looks like this, so I'm going to say 2. 5th roots of 18 is solutions to the equation x to the 5th equals 18. Here is x to the 5th. Here's 18. They cross once, so one solution. 6th roots of negative 41. Negative 41 looks like this. X to the 6 looks like this. They never cross. So 0 solutions. Solutions to the equation, that would be x to the 6th equals negative 41. 9th roots of negative 7 would be x to the 9th equals negative 7. Take the 9th root to solve that equation. And there's 1, because this is x to the 9th. Something like that. Here's negative 7. They cross once, so one solution there. 8 says the volume of a cube is 20 cubic feet. What is the length of an edge of the cube? Well, we know that volume of a cube is just s cubed, right? Where s is the side length of the cube. S times s times s gives you the volume of the cube. So then we get 20 equals s cubed, and solving for s, I can either take a cubed root or raise to the 1/3 power. So I get 20 to the 1/3 equals s, or the cubed root of 20 equals my side length. This one says compute the expressions mentally, no calculators. Well, this is asking us to find the cubed root of 27 and then raise it to the 4th power. Cubed root of 27 is 3, raised to the 4th is 81. This is asking us to find the 4th root of 10,000 and then raise it to the 7th power. Well, this is going to be 10, right? And then 10 to the 7th, I should just have 7 zeros. So it should be, let's see, how many zeros is that? 1, 2, 3, 5, 6, 7. So that's like 10 million, I think. 64, the 6th root of 64 is 2. And 2 to the 7th would be 64 times 2, or 128. Ooh, 32 to the 4/5 times 32 to the 2/5. That's got to be 32 to the 6/5, right? Because I can add these exponents. So the 5th root of 32, which is 2. 2 to the 6th is 64. Finally, Kepler's formula gives the average distance D of the sun from a planet with period of revolution R. Find the distance from the sun to Venus to the nearest million miles if Venus orbits the sun every 224.7 days. So I think they're just looking for D is equal to 1.82 times 224.7 all to the 2/3 power, and now you use your calculator. All right, and that's it.